Alright guys, welcome to lesson 9. In this lesson, if you made it to lesson 9, you should have had a pretty good job of mastering one rectangle and finding the area by making grids and the side length. That would actually be 4. And finding the area, 12 square units. Well, now in this lesson, we're going to look at taking more than one and finding the area. So we're going to be cutting in half this one to find the area of this and this. So you should have your problem set 9 as well as a blank, or not a blank, a sheet with a grid on it that you are going to be cutting in half. I won't be cutting it half because of being here on the computer, but you will be cutting it in half and then finding the area of both halves. Okay, so go ahead, if you don't have those, go get them, and then we'll move on over to the problem set. My problem set looks a little different than yours because I just cut and paste. I brought the grid, which is here. I brought the grid onto my sheet. These are the same questions you have. So what you need to do is have your paper, separate paper with the grid ready to go, like my grid is. And we're going to read the directions. So it says cut the grid into 2 equal rectangles. In order to find what 2 equal rectangles would be, we need to count how long this grid is. So we're going to count here as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 down. So half of 10, halfway to 10, is 5. So what you're going to need to do is, first of all, cut out your grid from your paper. So cut around the square like that. And we're going to count down 1, 2, 3, 4, 5. And you are going to make a cut right here on this line. Okay, so go ahead and do that. Go ahead and cut the thing apart. Pause the video and then cut it apart. So what you should have now is 2 different side lengths. You should have this side length. You should have that rectangle. And you should have this rectangle. And it's asking us to draw and label the side lengths of the 2 rectangles. Okay, so we can do that pretty easy. We can count the side lengths and draw and label those. So we got 1, 2, 3, 4, 5. So this one is 5. I'm going to change the color on that one to black. 5. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one has a side length of 10. We're going to do the same to the bottom. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now we have 2 rectangles with 2 side lengths. So we're going to write an equation. No, coming over here to B, it says to write an equation to find the area of one of the rectangles. Let's go ahead and choose the top one. And we have 10 and 5. So we're going to go, the equation is 10 times 5 equals 50. And now we have to add in square units. Now it's asking us to write an equation to show the total area of the 2 rectangles. Alright, here's how our equation is going to be. If we know one of the rectangles is 50, Then if we know the black one is 50, then the red one has to be 50 as well, because they're the same shape. So 50 plus 50 equals 100. Okay? So the area of the black one is the same as the area of the red one. We added them together. So the two equations we had to write was a multiplication equation and an addition equation. Alright, let's go ahead and move on to number 2. Don't forget the multiplication and addition, because we needed to find the area of one and then add the areas of both of the rectangles together to find the total was 100 square units. Okay, let's go ahead and move on to number 2. So now it's asking us to place your two equal rectangles side by side to create a new, longer rectangle. Draw an area model to show the new rectangle. Label the side lengths. So it's asking for an area model. If you remember from earlier, an area model does not mean we have to... You're going to take your rectangles, put them side by side, and count how many square units there are going across. Right, so you have, these are your two rectangles and they're side by side. One was 10 by 5, the other was 10 by 5. But since we put them next to each other, these two have to be added together. The 5s can stay the same. Matter of fact, we can erase this 5. And we add these 10s together and we end up with, so we got to take that and that, and we're going to add them together to give us 20 and 5. Now the area of the total, so that's what it should look like if you took the two halves that you cut and now you have a long, it's long, 20 square units long and 5 square units tall. And we're going to look at the total area. We need to do what? We need to multiply those two. So we have 20 times 5. And if you know your multiplication facts, you can either count them out, you can count by 5s, you can skip count by 20s. We know our facts, so we know it's 100 square units. And so that's what you're looking at for number 2A and B. If we go to the next page, we can see that it starts right down here with number 3, Fura. And this may be on your next page. The layout may have changed when I imported it. Furaha and Rahima use square tiles to make the rectangles shown below. So let's go to the next slide to see what the rectangles look like. Okay, those are the two rectangles. Now we're going to label the side lengths on the rectangles above and find the area of each rectangle. Okay, the way we do this is we count 1, 2, 3, 4. There's 4 on that side, and 1, 2, whoops, 1, don't forget to do that, 2, 3, 4, 5, 6. That one's 6. Now we're going to make the other one blue. We're going to go 1, 2, 3, 4. So we know it's the same height, and 1, 2, 3, 4, 5, 6, 7. So the area for each is a pretty simple multiplication sentence. 4 times 6 equals 24 square. Ooh, I should have done that in red. That's okay. Units. And the other one is 4 times what? 7 equals 28 square units. So Rahima's rectangle is definitely bigger. It has one extra column of 4, which is why it ends up being 28 square units, and Faraha's is 24 square units. Now let's go on to B here, and it says, Faraha pushes his rectangle next to Rahima's rectangle to form a new, longer rectangle. Draw an area model to show the new rectangle. Remember, area models aren't arrays, they're the rectangle without the array, and label the side lengths. So if we push them together, it becomes one new rectangle. And we're going to find this. We know that the side length is 4 because it's 4 for both of them, so we don't need to add those together. And we're going to add this to this. Okay? So we're imagining we pushed them together, and now we have to add 6 plus 7, and that gives us 13. Because we pushed this one into that one. So we have a side length that's the same, 4, and we have 13. And so we've done what we asked. This is our area model. This is right in here. With the 13 and the 4, you notice there's no array in there because it's an area model. And Rahima says the area of the new, longer rectangle is 52 square units. Is she right? Explain your answer. We could say, we got to find out what, we could either add 24, because remember that's what the area of 1 plus 28, since we put them together. You know your math, and that ends up being 52, so it looks right. Or we can go 4 times 13, which is one of the new side lengths. And skip counting or knowing multiplication facts, that also gives us 52. She is right. And number 4. Kiara says she can find the area of the long rectangle below by adding the areas of rectangle A and B. Is she right? Why or why not? So this is kind of what we've done, is we've taken 2 different rectangles and pushed them together to make one long one. The question is that what happened here? And if you look at the one I just drew compared to this one, there are some similarities and difference. There are 2 rectangles. They are pushed together. However, in this one, rectangle B goes over rectangle A. So I would say that she cannot find the area of rectangles A and B in this way because one goes over the other. Whereas here, they're pushed together in a half. So I would say no, because they cross each other. And you can't find that if one overlaps the other, if one goes past the other one, like it did right here for rectangle B. And on the other, or maybe it was rectangle A that went into rectangle B. They have to be more like this, next to each other, to make a new rectangle. This isn't making a new rectangle, this is going beyond that spot. So for the rest of the time, you're going to be putting rectangles together and taking them apart into smaller rectangles or making bigger rectangles. Good luck on the homework and problem set, and I'll see you in lesson 13.